Thank you, Dr. Tipti Goel, ma'am, for the brief introduction. A very good afternoon to all of you. So I hope all of you are well during this COVID-19 pandemic. So I also expect that you are enjoying this webinar. So today I am going to present uh, hand gesture recognition for human-computer interaction. So this is the outline of my presentation. This first, I will briefly talk about what is computer vision, because some participant may not be familiar with this subject. So I will go through brief about it. Then I will shift to hand gesture recognition, one of the prominent field for human-computer interaction nowadays. Then one of the major applications of hand gesture recognition is sign language recognition. So I'll talk on that also. Then also talk some research problems in both these fields. And then finally, I'll show you how to implement some practical computer vision system using OpenCV on Python. So finally, I'll take your questions. So what is a computer vision? So as we know, every picture tells a story. So if I ask any one of you, okay, what will you see, what you see in this picture, then you can easily answer. But answer may be various. Something someone may say, I have seen one TV, two fans, then one AC, two beds, then color of the bed sheet are yellow, so like that. So we can describe this image in various ways. So now, how a computer actually will describe this image? That is the basically the goal of computer vision, to write computer program that can interpret images and videos. Okay, our human visual system can easily describe this image, but how a computer will describe or interpret this image? That is basically the goal of computer vision. So input to the computer vision system is image or video data, and output is some interference about the world or the interpretation of the image or video data. So how does a computer vision work? So the top figure shows our human
Hello, sir. Some network issue may be there, so wait for some time. He left, no? Yes, sir. Yes, sir.
Okay, sorry for the interruption. Technical
Technical
problem.
issue.
Yes. Sorry. So I have to start from the beginning, I think.
Yes, sir. You have to start from first slide.
Okay. So very good afternoon to all of you. So I am going to present hand gesture recognition for human-computer interaction. So this is the outline of today's presentation. First, I'll briefly talk about what is computer vision, because some of you may not be familiar with this. So I'll briefly talk about that. Then I'll talk about hand gesture recognition, which is one of the
Yes. Anjan, sir. Sir,
yes.
please share your presentation slides. Share
Which
the
one?
slides.
Okay.
Slides.
Okay.
Slides are not visible.
Oh yes. So so good afternoon, everyone. So today I am going to present on hand gesture recognition for human-computer interaction. So this is the outline for today's presentation. First, I'll briefly talk about computer vision, uh, because some of you may not be familiar with this field, so I'll briefly go through that. Then I'll talk about hand gesture recognition, which is uh, nowadays a prominent technology for human-computer interaction. Then I'll talk about sign language recognition, which is one of the major applications of hand gesture recognition. Then finally, I'll briefly show you OpenCV, means Open Computer Vision Library, for implementing any computer vision project using Python. Then finally, I'll take your questions. So what is a computer vision? So every picture tells a story. If a human is asked what he or she has seen in this picture, so he or she will quickly give answers like, I have seen a TV, or he or she may tell that I have seen two fans, one AC, two beds, etc. etc. So it is not a difficult task for a human being, except the child, which for an adult human being, it is not a very difficult problem to describe this image in various ways. But how a computer will describe it? That is the basically goal of computer vision, to write a computer program that can interpret images and videos. Okay, so input to computer vision systems uh, is image or maybe video data, and this computer vision block will take this input and do some processing on that input and give some interpretation of the image or video as output. Okay, so this is basically the computer vision problem. So now, how does computer vision work? Actually, so this above figure shows how a human vision system works. So suppose this is one picture. So we'll look at this suppose image through our eyes, and so I will capture the signals will be formed on the retina of the eye, and those signals will go to the processing unit of brain. The brain will process those signals and will give some output like bowl, oranges, bananas, lemon, etc. So here actually our eyes are the sensors. They work as sensors, and human brain works as processing unit. Now, so in computer vision, actually, we are trying to replicate this human vision system with the help of a computer and a sensing device. So in computer vision, suppose input is same, and our sensing device is generally a camera or some other devices also. I'll discuss about those also. Then suppose the camera captures the image, then that image is sent to the interpreting device, suppose a computer, and the computer will process that image and apply its various algorithms, various models. So ultimately, it will give outputs like bowls, orange, bananas, lemon, etc. So this is actually the comparison between the two, human vision system and computer vision system. Now, why it is important actually? So it is important because of tremendous amount of applications nowadays. I will briefly discuss some of them. First one is about optical character recognition. So what is optical character recognition? It is a technology to convert scanned documents into text. One application can be license plate readers. So this is the scan uh, image of the license plate, and this is the output where we are reading the digits or letters present on the number plate. So now nowadays this automatic number plate recognition system is being applied. So you can see on this image, the right side image, that this technology is being used for detecting the number plate. So then second application can be your face detection. So nowadays most of you have smart cameras. So you have smart mobiles. So in your smart mobile phones, your smart cameras are there. So these cameras can not only capture image, but also it detects faces or even your age also in some cases, and many features are there. Okay, so these are becoming possible only because of this computer vision technology. Then object detection and recognition. So you can see from this image that various objects that are present on the image are being detected. This is building, this is human, this is bag. Okay, so like that. So this is not only detecting but also localizing. This means it is also finding where is it, where is the human, where is the bicycle. So this is the object detection and also recognition. So next application can be your vision based biometrics. Okay. So nowadays we use this kind of biometrics like fingerprints or this iris recognition. So this iris recognition actually is one of the applications of computer vision based system. So this is a nice example we can discuss for this iris recognition. There is a story actually behind this. That this Sai Sarbat Gula, she is basically from Afghanistan, but during the invasion in Afghanistan, she fled with her family to Pakistan. So one photographer actually captured her image because her eyes are green in color. So this is the peculiarity she had. So and the photographer uh, took her image. But after almost 17 years, when the same photographer tried to find her, uh, it was difficult to find her because this was the picture of the same lady Sarvat Gula in 2002. So actually, with the help of this iris recognition, it was detected that she is the same as girl Sarvat Gula. So actually, because our iris has one peculiar pattern which is unique and does not match with others. So this iris recognition can be used as one of the important biometric techniques. So then, as you know that this feature is also now come to our mobile phones. Login without a password means it basically takes your iris as input, and it detects whether you are the authorized person or not. So this technology has already come. Then in movies also we see some special effects. So this movie, I think you can remember, this is the Matrix movie, right? So here actually what is done, suppose this is a person, first his 3D shape is model like this way. Uh, so by using cameras from various sites. So first a 3D model of that person is model, and then we vary the parameters of the model to uh, generate various replica of the same person. You can see in the background the same person but with various expressions or like that. So this technology was also used in that movie. So then augmented reality, as you know, this is basically mixing of your virtual and reality. So it has now many applications. So for example, here suppose this person is going to buy one sofa, so he can actually taste whether that sofa will be matching in his room or not. Actually this background image is the real image of this room, but the sofa is the virtual. Okay, so it is a mixing of this real and the virtual. So apart from this also it has many applications. So then self-driving cars is also coming. So so without driving also the car can determine its path and other parameters. Okay, so for that one is camera is there, or some radar actually. This system is there. Then uh, and this is also one very important area, that security and surveillance. Okay, so nowadays this is also being deployed for security and surveillance. So then now in present situation, means in COVID-19 pandemic, how computer vision can play an important role. So people have already done works on it. For example, for mask detection, whether a person is wearing mask or not. So this kind of detector has been already implemented. For example, you can see that here this no mask, then mask, no mask, so like that. You can use computer vision technique for this also. Then social distance violators, you can check whether people are maintaining social distancing norms or not. For example, if the green box is coming, means they are maintaining social distancing. But if it becomes red, means they are violating the social distancing norms. So similarly, thermal imaging is also becoming one very important for this situation, that with the help of thermal image we can detect whether person is having some fever or any symptoms or not. So for example, this is the image taken at the Taiwan International Airport in Taipei. So basically it is believed that number of people infected in Taiwan was very less because of this technology they implemented. So now these are some applications in general, and now I am going to discuss some application related to your biomedical applications, because I believe that many people have joined this workshop to know about machine learning applications in biomedical and health sciences. So I will be discussing briefly about how computer vision is playing important roles in healthcare. So so these are the actually major areas where researches are going on, and those who are interested may work on these fields. So I'll briefly discuss these three fields. One is diagnostic, then medical imaging, and then surgery. So how computer vision is playing its role in these fields. So first, diagnostic. So one actually software called Inner Eye, that is produced by Microsoft. Actually, so a software from Microsoft, and it claims that it can visually identify and display possible tumors and other anomalies in X-ray images. So, for example, you can see this portion, this white boundary portion. Actually, there is a tumor there. So, this software can detect this tumor, and once you detect this tumor, and if you mark it, then you can see the 3D shape of this tumor. So it helps to diagnose this tumor and also do operation this tumor very easily. And the important thing is that it takes very less time compared to manual diagnostics. So the second application can be medical imaging. So one company called Arteris, they have produced one software, a machine vision software that detects abnormalities in the heart. So their algorithm is known as Arteris 4D flow, and so they detect abnormalities in the heart and also can create three-dimensional model uh, of the patient's heart. And this software is installed on a standard MRI machine. So this is how you can also even monitor the blood flow through this heart and everything. So that's this is one application. Then other application can be your 3D imaging. In case of MRI on CT scan, you can have 3D image. Also, this is right hand side is an image of image guided surgery. So like that, you can have a 3D model of this tumor, suppose, and also the brain. So it is helpful for robotic surgery or also remote surgery. That it helps in those cases. Then in surgery also one software called Triton, that is offered by one company called GUIST. Okay, so it helps actually physicians to monitor surgical blood using computer vision on iPad. So what is done basically, actually this soak blood towels or these sponges are actually displayed in front of this camera, and this camera captures this image and it processes this image, and ultimately it determines how much blood was lost by the patient, like that. So they have not disclosed their algorithm, but it is working fine. Then this is some application in case of medical fields. So now I will briefly go through a history of computer vision, actually, how it actually came. So computer vision started to take shape in 1960. So it aim was to try and mimic human vision system and ask computers to tell us what they see. Okay, so initially in around 1965, basic features were actually detected like shape, boundary, etc. Then in mid around 2010, artificial intelligence came into play. It was mixed with the computer vision algorithm, and so image recognition became very uh, easier. So basically, these new features were added also. Then segmentation techniques were also improved. So this is how the computer vision techniques were evolving. Then nowadays, this is the present situation that deep learning has come into play. So improved deep learning techniques and technology is now being used for faster and accurate results. So now this is a journey, and I will now go through some important phenomena, like in 1959, actually, how actually computer vision started. We can say from 1959 that David Hubel and Thorsten Wiesel, these two professor, actually, they tried one experiment on a cat, actually. They placed some recording electrode on visual area of brain, and they recorded electrical signals from the brain. And actually, they gave some stimulus here, like they were changing the pictures, they were giving various shapes here. Then they record the response, actually. So initially they did not get any result, but after a few months, suddenly or accidentally, they saw that one neuron fired as they were slipping a new slide into the projector. So this is some accidental result that was observed, and we can say this is the starting point of artificial neural network or deep learning network that is being used nowadays. So although it has no direct connection with computer vision, then one major invention was that digital image scanner by Russell Keys in 1959 and his colleagues. Actually, he is the we can say inventor of pixels or digital images. So it is because of that we now can process digital images in various ways. So now this is the actually first image, that was first digital image, we can say, that was captured. It was of 30,976 pixel, and its size is about 176 by 176. Actually, he is the son of Russell. He was the son of Russell Peace, and now this image is stored in the Portland Art Museum. So this is one major invention in this field. So then one major invention was that Lawrence Roberts, this paper, Machine Perception of Three-Dimensional Solids, actually he described the process of deriving 3D information about solid objects from 2D photographs. So what he did actually, he extracted the lines from the object, and then he removed the inner lines, and then we got the some 3D view of the object. So this is also considered one of the major milestone in this field. So then actually in 1966, Seymour Papert, a professor from MIT's AI lab, decided to launch a summer vision project. Okay, so he asked a small group of MIT students to develop a significant part of visual system in one semester. Basically, he asked to segment the foreground object from the background and to recognize that. So, although it was not completed in this semester, but this is considered as the official birth of computer vision as a scientific field. So we can say that from this project actually the computer vision started. uh, so this is about brief history of computer vision. Now you might be confused, what is the difference between image processing and computer vision? So so in case of image processing, our input is image, and our output is also image. Okay, we do some processing or transformation of the input image, and ultimately we get some output image. Okay, we basically do some filtering, or as the name image processing, so it's input and output, both are images. But in case of computer vision, your input is image, but output is some interpretation of the image. Okay? For example, what are the objects there, what are the colors of the objects, how many objects are there, etc., etc. Okay, so but this image processing plays an important role in computer vision, because to model this computer vision problem, the image processing helps a lot. So we can say image processing is a part of the whole computer vision system. So till now I have talked about what is computer vision, briefly about computer vision, its applications, and a brief history of also computer vision, and a comparison between image processing and computer vision. So this is about computer vision. Now I'm going to discuss on application of computer vision, that is hand gesture recognition. So what is a gesture basically? So a gesture is basically a movement of the body parts that contain information and feelings. Okay, so we always in our day-to-day life also we use our gestures to convey some informations, right? So this is basically gesture. You can see some hand gesture in here, and also the right hand side you can see some facial gesture. Okay, we express some our feelings, our emotion through our facial expressions also. So this is also one type of gesture. Now what is gesture recognition basically? So gesture recognition is the recognition or the understanding of the gesture by a computer or a machine. Okay, so this is basically the gesture recognition. So in case of gesture recognition, our input is a gesture which is given by the user. Then our sensor, basically the camera, detects the gesture, reduces it into signals and passes it to the device. So then the processing device processes these signals and perform the task as conveyed by the gesture and give the output. So it will interpret as this. Suppose gesture that you have owned. Okay, so this is basically the working of the gesture recognition system. Now, applications of gesture recognition. It has many applications nowadays. First of all, suppose in video game controller. So nowadays, smart TVs and smart cameras are coming. For example, Microsoft Xbox is a nice example. It uses one camera called Kinect sensor. I'll show it in later part. So here what happens, you can directly actually interact with the game or the player. So suppose you are kicking, then this player will also kick. Okay, so like that. So in means real time, you can directly uh, interact with the game. Okay, so this one application in video game controllers. Then aid to physically challenge. So the people who have some motor neuron problems or some who are visually impaired, so they can use this actually chair. Okay, so so basically here sensors are there. So with the help of your hand gesture, we can control this chair actually, its speed, its direction. So everything is controlled just by one hand gesture or finger movement. So this one example. Then human computer interaction. Now smart TVs are coming to the market where you with the help of your gesture you can control your TV. So no remote is required. Your hand is your remote actually. So that is also coming nowadays in smart TVs. Then in case of medical field also, it has many application. For example, suppose a doctor is doing some operation, so he is wearing gloves, so he can't touch the machine, but he has to control the machine to see some images or like that. So with the without touching this machine, with the help of gestures, he or she can control this machine. So it is playing a very important role in case of surgery or medical applications. Then sign language interpreter. So this is also one very important application of gesture recognition system. This sign language recognition. So what is sign language basically? Sign language is the language used by deaf and dumb people. So so many of us don't know sign language. Only those hearing impaired people know the sign language and they communicate among them. But to communicate with hearing impaired people by healthy people like us, so we have to learn sign language, but it is very difficult to learn sign language also. So in that case, the sign language interpreter can help us, that it can convert the sign language into some audible text or speech signal, which is understood by one healthy people or vice versa. So in that case, the sign language interpreter is actually bridging the gap between the hearing impaired people and the healthy people. Then one more important field is the virtual reality. So as its name suggests, uh, it's a virtual environment is actually built surrounding the user or surrounding us. So, but it seems to be real. So we can directly interact with this virtual environment. So I think you are familiar with this virtual reality. So this is also becoming possible only because of the hand gesture recognition system. Now, what are the approaches for gesture recognition system or the sensing technologies that are used? So there can be two approaches. For example, one can be your vision based and sensor based. So in case of vision based, basically the cameras are used. Okay, and so we can use a single camera, or we can use stereo camera having two cameras, uh, and then we can also use some haptic techniques which uses some IR sensors also along with the camera, RGB camera, like Kinect or leap motion controller, etc. And in case of sensor based, actually, uh, we can use some inertial measurement unit based sensors, or electromyography or EMG signal based sensor, or Wi-Fi or other field sense based sensor. But if you compare these two, vision based and sensor based, actually accuracy in case of sensor based approaches are more compared to vision based. But problem is that the user has to wear the sensor or the globe on his or her hand. So so it is difficult to move the hand freely. This is one drawback. If you wear this sensor, then it is difficult to do the free movement. And also they are costly also. These sensors are very costly also. But in case of vision based, you can freely move your hand and they are less costly also. But accuracy is more in case of sensor based. Basically, in sensor based, okay, I will discuss this. Uh, so in case of vision based, we can use single RGB web camera like this, but we should not use a camera with very high resolution. We should use a camera with medium resolution, not very high, because if your resolution is very high, image size will be more, and the processing algorithms will take much time to process your images. So that is why we should use some images with some low or medium resolution. Then we can, but in case of single RGB camera, we only get two-dimensional information or 2D image. But if you go for stereo camera, means camera, two cameras uh, at a time, so you can extract the 3D information also. So this is one Minero 3D webcam you can see. Uh, so this is a multipolar geometry which is used to represent this stereo camera, and using this technique actually we can find the third information, that means the Z or the depth information from these two cameras. This is a depth information, so we can extract this depth information. For example, suppose this is one same scene. This is captured by left image, this is captured by right image, and this is actually the disparity map, which is giving you the information about the depth. And this is basically a 3D projection of this depth image. So means with the help of stereo camera, we can not only extract that 2D information, but also depth information or the 3D information. Then one more camera is there, that is called Microsoft Kinect. As I have already told that in case of gaming, we use this Kinect also. But what are the advantages of Kinect sensor? Basically, in Kinect sensor there are two cameras, RGB cameras. Along with this one, IR sensor is also there. So this IR sensor actually it detects the Z information also. So it basically gives three outputs. First one is that you can easily draw the skeleton of the object. Suppose this is your RGB image, and these are the skeletons of these two people. So skeleton information is easily extracted. and this is the depth information actually. So we can have the depth information also, means which person is nearer to this camera, which is uh, far from this camera, so we can easily determine that. Then sensor based, that is inertial measurement image based sensor suppose. So this is one image of this kind of sensor. Basically these sensors determine basically the uh, angle information between the joint angles of the fingers, etc. Also to determine movement of the fingers like acceleration, velocity, angle movements, etc. So that's why they are very accurate, but they are costly. So these are the various sensing devices that are used for hand gesture recognition. And what are types of hand gestures now? So So basically, gestures are two types. You can say one is static and dynamic. So in static gesture, what happens? Your hand or your fingers are static. But in case of dynamic, there's a movement of the hand or fingers. So this figure will show you. These are the static gestures, and this is your dynamic gestures, where the hand or the fingers they are actually moving. Means there's a global motion of the hand or fingers. As you can see here, this sign is recognized as O by this computer. Then application of sign language recognition system uh, can be your sign language interpreter.
So, कहाँ से हो?
So, what is sign language interpreter? Basically, the sign language interpreter is the can say interpreter that or device that can convert a sign language into some form of text or speech. Okay, so, as I have already told that our healthy people generally find it difficult to communicate with hearing impaired people through sign language because they don't know sign language. So if there is one sign language interpreter, so with the help of that sign language interpreter, we can communicate with them also, and it can be placed in various places like airports, railways, banks, etc., etc. So so it can bridge the gap between us hearing impaired and healthy people. Now, challenges in sign language recognition systems. So there are many challenges that come in sign language recognition system. Some of them are like occlusions. So what is occlusion? Basically, when one body part comes over the other body part, that is called occlusion. As you can see here, this hand or this palm part is coming above this face part. So this is one occlusion problem. Similarly, here also we can see this finger your is coming is on above this palm. So this index finger is coming above this palm. So this is occlusion problem. Similarly, dynamic background. So in dynamic background means if your big background is moving, suppose it's not static. Suppose you are moving in a car, in a train, or like that. So the background may be moving. Then complex background. So here you can see that a complex background means the background contains many things of various color, various shapes. Okay, so this is so from this complex background, it is difficult to segment the sign or part or the palm or hand part. So this is one major problem. There's complex background. Then variable lighting condition. As you can see here, the lighting condition may be varying. Sometimes it may be darker, sometimes it may be brighter. So it is very difficult to basically segment the hand part from the background for the variation of lighting conditions. Then a real-time application. So what is real-time application? Means your recognition should be very fast. You have to recognize a sign before the next sign uh, is entered. So its recognition should be very fast. Then also one more problem is there. It is called variation in sign language with locality. It means the sign language that is used, suppose in Delhi, that language may not be used in Mumbai also. So there may be some variation. So that is also one problem in Indian sign language system. So apart from this, if you consider more problems in continuous sign language recognition system. So sign language recognition sign languages can be two types. One can be your static, and another can sorry isolated. Another can be your continuous. So in case of isolated sign language, we use one single sign at a time. But in case of continuous sign language, for example, in case of sentence, one sign is followed by other signs in a single video. So it means there is a continuous sequences of signs. That is the continuous sign language recognition. Sorry, continuous sign language. So actually, a sign language consists of these two parts: one, the finger spelling and the sign. So what are finger spelling? Finger spellings are the your basically the static signs. as you can see here, alphabets, for alphabets we use static signs or finger spellings like A, F, K. For the all the 16 alphabets except Z and Z, all are static. But and others, so these finger spellings are used basically to articulate and suppose name of place or name of the person, etc., for which actually no particular vocabulary is are there. But in and signs are the actually language for which actually vocabularies are there, which some dictionaries they are already there. For example, this suppose and big arrive here. So these are signs with some vocabulary. Okay. So now a complete sign may language may contain the mixing of both. For example, if I write one sentence like arrive Mary yesterday. So for arrive and Mary, there are defined signs. But for Mary, we have to spell each of the letter one by one, M-A-R-Y, because this is a proper noun and there is no particular dictionary for it. So now what is the problem in this continuous sign language recognition? That one problem is called movement appendices. So what is movement appendices problem? Basically, when we move from one sign to other sign, so there is a joining part, means some extra movement of the hand from one position to other position, means from the correct position to incorrect position. So that is called basically a movement appendices, okay, which is not the part of the actual signs, but they are arising because of the continuous sign language. So and second problem is the co-articulation. So what is co-articulation problem? Basically, um, mm, the one problem there is co-articulation, that is the articulation of the current sign is affected by its previous as well as its future sign. Okay, so suppose this is our S is the current sign. So the articulation or shape of the sign in case of continuous case will be different from its isolated case. Okay, its shape will be varying from its isolated case because of the effects of this previous sign as well as of the next sign. So also there are two problems basically. One is called assimilation and dissimilation problem. Suppose in case suppose here you can see the suppose C, this letter C and this letter A, uh, they are almost similar. They have similarity. Uh, okay. So, so what happens if C is followed by A? Then articulation of S will be affected by this because they are similar. But if C is followed by U, then effect on this articulation will be different. So this is one major problem in case of continuous sign language. For example, suppose there are two words, one is discuss and discard. So in case of discuss, S is sorry, C is followed by U. Okay, and in case of discard, C is followed by A. So here you can see C is followed by U and C is followed by A. So in both these cases, the articulation of the letter S will be different because of this problem, as I have already told. This assimilation and dissimilation. This is assimilation problem. That is because they are almost similar, and this is dissimilation case that they are different. There is a significant difference between this. So this is about some problems. There are again many problems for co-articulation that I have not discussed here because of the time constraint. So I've just given a glimpse of that. So now we come to the last part of my presentation, that is OpenCV using Python. So many of you may be familiar or may not be familiar with this OpenCV library to implement this OpenCV based projects. So I'll just briefly give you some idea so that we can start. So basically, what is OpenCV? So this is an open source computer vision and machine learning software library. Uh, so actually, it is basically built for computer vision and machine learning applications, and it is open source. So it contains more than 2,500 optimized algorithms, and it was started at Intel in 1999 by Gary Bretzke, and the first release came out in 2000. And it supports a wide variety of programming languages like C++, Python, Java, etc. So, so now OpenCV Python. So OpenCV Python is the Python API of OpenCV. So it combines the base qualities of OpenCV, C++ API, and Python languages. So now why Python? Actually, why Python language? Or what is Python basically? I think most of you have the idea. So I'll just give you the brief idea about Python. That it is a high-level language. So it is also open source, and it is interpreted language. What is interpreted language? Basically, means while you are writing the code, suppose at that instant only it is compiled. So means if there is an error in your code, it will be shown at that moment only. So it is basically interpreted language. It does not wait for completing the whole program like other languages. Here, at the moment you write the code, it will compile and it will check. Okay, like that. So now, why learn Python actually? Why people are using Python nowadays? Because it takes has reduced development time, reduced code length, easy to learn and use as developers, right? Easy to understand codes, and easy to do team projects. Okay, easy to extend to other languages. So I will not discuss Python here because it will take again more time. So and there are many resources for which you can learn Python also. So now OpenCV Python installation. I'll give you brief idea how to install Python and OpenCV in your system. So if you are using Linux system, then install Anaconda. Actually, Anaconda is the complete package actually that contains all the library related to Python. Okay, so otherwise you have to install Python separately, but better to install Anaconda. It contains all the supported libraries and packages. Then you can install OpenCV. Just simply typing pip install OpenCV Python. This version you can type, but whatever is the current version you can type here, and you can install it. So I'll show you how to do that. Suppose in case of Windows, download and install Anaconda environment and Python 3.7. Okay, from the Anaconda website, you can download it. Then after downloading or installing the Anaconda, then you go to Anaconda prompt and type this pip install OpenCV Python 3.4. Whatever this version you want to download. Then also you write, after completing this, then you write then second one, then you download the second one also. So means then whether your download is okay or not, you can check by typing import CV2 in the IPython console. If no error is shown, then that means your installation is proper. Okay, import CV2 means your CV2 is the actual library that we are importing, suppose. So if this no error is coming, means your installation is okay. Now I will briefly show you how to read, display and saving images in case of OpenCV. So for that, suppose import first, you have to write first import CV2 to import the supported libraries of computer vision. Then you read the image using cv2.imread command. Then this is the name of the image. Then you can you can show your image by using the cvt.imshow. Then name of the window you are giving. Then name of the image, this image. Okay. Then cv2.wait key. Okay. So what does it mean? Means this image will be displayed the output unless and until you don't touch any keyboard. Whenever you touch the keyboard, then this program will be closed. So then suppose this is just to display, read and display an image, and this is how to save the image actually. Suppose loading and saving an image, you are suppose loading the image, also you are converting into a grayscale. Okay, along with reading, you are also converting this RGB image to suppose grayscale. Then cv2.imread underscore grayscale you have to use. Then you can display both the original image and the grayscale also. Suppose display the grayscale image. There is a grayscale window. This is the name of the window. Grayscale. Then gray underscore image. So that will display the image. Okay. With by opening a window called grayscale. Okay. Then after that you can save this image. Suppose cv2.imwrite. For that the command is cv2.imwrite. Okay. Then you write the name of the image. Then the name of the file name you want to save the image. Then name of the image you want to save. Then again cv2. So this will save your image. Then comes suppose videos, how to read videos. So for that you have to import suppose NumPy. NumPy is also an additional library for numerical calculations. Basically it provides arrays and all functions. So first you import NumPy, then import cv2, then you have to then you can read the video by using this command cv2.video capture. Suppose this is the name of the video. Okay, so this okay, you can if you write here suppose 0, then that means it will take the video from the camera directly. Okay, if instead of reading some stored video, you can directly read video from the camera also. Then you have to use argument 0 for the first camera, or you can use 1 for the second camera, like that. Then you can check whether it is perfectly capturing the video or not. You can check if not, caps is cap dot is open, then raise this error, display this line that cannot open webcam, and otherwise while true you can read the frame frame by frame. Okay, then you can input display the frames one by one, and you can use cvt.waitKey.1. That means here you can wait for 1 millisecond. Means one frame will be displayed for suppose 1 millisecond. And if c is equal to 27, means we have put the condition that if you press the ST key, then your file will be closed and it will stop capturing the video. Okay. Then we can release the window and then you can destroy all the windows. So Okay, so this is how to read a video from camera or from your drives. Now I'll briefly show one program for American Sign Language recognition, basically for binary classification. Suppose I am considering two letters A and E. Okay, I want to classify whether the input letter is A or input sign is A or input sign is E. Okay, so this is basically my block diagram. So first I have suppose read the input image frame. Okay, then I have removed first the face part. Okay, we have to remove the face part because I am going to use skin color based segmentation technique to segment the this palm or from the background. So that's why as skin color is matching, the skin color of the face is matching with the skin color of this palm. So that's why first I have to remove this face. So I have used face removal technique using hair classifier. Okay, then after removing the face, uh, now actually I have converted this RGB image to some HSB image. Okay, so that segmentation becomes easier because in case of RGB you have to control three parameters R, G, and B. But if you convert it to HSB or YUV, then color and intensity part will be separated. So you can easily segment the color part using hue and saturation parameter. Okay, so that is the technique. So then after that I have segmented this hand. Also I have localized this hand, suppose. Then I will use hop features, actually histogram oriented gradient feature. Okay, so proposed by Navneet Dalal. Uh, he's, a, he's an Indian also. So I will be using hop features, histogram oriented gradient feature. Then I will train this classifier called support vector machine for different signs of A and E. Okay. So after once training is done, I will input the any letter A or E as input and check whether it is classified or not. So for that, this is my actually programming part. Uh, so first, let me first run this code. So here you can see first this was our input image. Okay, then I have removed the face using hair classifier. Then I have used the skin color based segmentation. Now you can see I have used the skin color based segmentation to segment this skin part on the background. So as you can see, this part of the skin and this part of the skin is still coming. So we have to remove this part. But we can first remove these small small parts using dilation and erosion technique. So I have used first dilation, then erosion also to remove some parts. Then finally, I have used a contour matching based technique actually. So I have found the contours of all these parts, and I have selected a larger contour. Means the contour having the largest area. So here obviously this palm part will have the largest area. So I have removed the other parts and only kept the palm part. Okay, so I have so now this is how I have segmented the palm part from the background. So now after that I want to cut this part actually so that I can directly input this image to the hog fisher detector. So for that, I have sorry separated this part from the background. Okay, so this part I have separated. This now this is now my now new image uh, for fisher extraction. Now then I have used hog fisher extractor. Then finally I have used the classifier. Now I will show you step one by one. So first I have this imported this CV2 and NumPy. Then this face cascade classifier means hard classifier for face detector. It is already there in the OpenCV library. You can directly use it. It can be used for other detection also, not only face. You can use it for detection of human or any other objects also, but for that you have to train it before that. So now then I have read the input image, suppose means this image, then I have converted it into grayscale image so that I can apply this hard classifier. So I have applied hard classifier, then detected the face part, and then to remove this face part, I have used this part basically. To first I have uh, constructed a mask actually, and then I have removed the face. So here actually x, y, w, h are the x, y is the center of the point, corner points, and w and h are the width and height. So then for after removing the face, it then comes your then I have converted this RGB image to HSB image. Then I have selected the threshold values for skin color. Okay. Then lower values for HSB plane is 0, 20, and 40, and higher values are 35, 180, and 25. This is I have actually selected manually by going through the pixel values of this image for skin color. Then I have uh, removed the then I have made a mask using these threshold values, and then I applied this mask on this original image, and this is basically nothing but the bitwise AND operation or the color based segmentation. Then I have shown the segmented image. Then this is for dilation and erosion. It may not be required in some cases. If required, you can use it. Then this is the code for finding contours areas. Okay, first we have found how many contours are there by using this command cv2.find contours. After finding the number of contours, we have found the area of each contour, and we have selected finally the contour with larger index, max index. We have selected the contour with larger index, basically for the palm part. Okay, then we have created one bounding box for selecting the palm part using the cv2.bounding function. Then I have separated the palm from the background for the hog feature extractor. Now we can now define the hog feature extractor here as a function. We can, this is the for hog extractor part, and you can input this as a hog. Now you can give your segmented palm part as input to the hog extractor, and finally it will give you the hog features. Likewise, after extracting the hog features, I can now train the classifier. So for classification, actually, suppose we have to use sklearn library for a SVM, that means the support vector machine classifier. So first I have imported this sklearn library. Then I have inputted all the input feature vectors for both A and E. You can generate a separate file also for that. Then you can read the file also. Then this is suppose our input level or input features. X is our input feature vectors, this matrix. Then Y is our output classes. Suppose 0 for A, 1 for E. Then I have used a linear SVM classifier. Then I have, this is a training part. Okay. Then clf.fit will train the SVM, and for testing, suppose after training is done, you can test whether it is perfectly classifying or not. Then you can, suppose I have given another input for testing. Then I have, if you run it, you can now this predict the output using this command. Okay, so once you run it, now before that I have to close all the other previous windows. Actually, how to close it? Actually, you have to first press on the image, and you have to then press the ST key. Then it will be closed. Previous program will be closed. Okay. So now you can run this program. Now it's being run. So we have tested for two signs, one for E, one for A. Actually, this is the actually input feature vector for E. So it is giving output as 1, and this was the input feature vector for A. So it is giving output as 0. So this is how actually we can build one gesture recognition based system in Python using OpenCV library. Okay. So this is the just to give you a brief idea so that you can start with this library. Then you can learn many things step by step. So this is about my today's class. Now for any query I can, okay, for that I think I have to go so madam.
Sir, only two queries were there. How many seconds computer take to detect the hand gestures?
That is a question that is coming.
Sir, how many seconds computer take to detect the hand gesture?
Okay. Actually, I have not checked that part, but you can check. There is a command in OpenCV. Using that command, you can find out the time taken for calculation. Yeah, you can do. That is important if you are comparing with some other techniques or some processing time. And then it is important. Yes, you can do that. You can find that, but I have not calculated that. Yes.
Okay, so second question is, if augmented reality and virtual reality is the part of
Yes.
computer vision?
Yes. 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 There are some applications of computer vision.
Can we detect whole human system through hand gestures and diagnose the disease?
Sorry.
Can we detect whole human system through hand gesture and diagnose the disease?
Whole human.
System through hand gesture.
Whole human system.
Yes.
Okay.
Okay.
See, you can observe his gesturing. Suppose his or her gesturing, whether his gesturing is okay or not. Suppose if he has some neuron problem, motor neuron problem, he or she may not be able to do the gesturing properly. So this can be actually one technique through which we can detect some kind of diseases for a person, or we can detect his gait or walking style, suppose, or from those we can determine his walking style is okay or not, or his posture, means sitting posture, or these are okay or normal or not. So by observing those things also we can detect whether a person is maybe having some health problem, like that.
Okay, sir. That's all with the questions, queries.
Okay.
Thank you, sir.
Okay. Welcome. Okay, so thank you all for giving the time and listening the presentation. And particularly thank you to Dipti ma'am.
Yeah. Okay, sir. Dear participants, now we have next session tomorrow at 11:30. Okay. So this is for your kind information. Tomorrow we will gather again for the next session at 11:30.
Okay. Thank you.